Real number system. This topic should be new to you. You probably haven't discussed it before because it's an eighth grade concept. So you may want to take some notes on this. It's not a big concept, but it is still one you need to know. Real numbers consist of all the rational and irrational numbers. The real number system has many subsets: natural numbers, whole numbers, integers. Natural numbers are your set of counting numbers. First number you ever learned: 1, 2, 3, 4, 5. Those are natural numbers, and so on. Whole numbers are the set of numbers that include zero. So they're part of natural numbers. You just add zero to it. Integers are the set of whole numbers and their opposites. So now your negatives come in there. So your integers include your whole numbers and your natural numbers. Rational numbers are any numbers that can be expressed in the form of a divided by b, where a and b are integers and b does not equal 0. They can always be expressed by using terminating decimals or repeating decimals. Terminating decimals are decimals that contain a finite number of digits. Example, 36.8, 0.125, 4.5. There's an end to the numbers. Repeating decimals are decimals that contain an infinite number of digits. They go on and on forever, repeating the same digits. 33333, 1.9999. Remember that bar means you're repeating. And 7.689, 689, 689. It'll keep repeating. Irrational numbers are any numbers that cannot be expressed as a divided by b. They are expressed as non-terminating, non-repeating decimals. Decimals that go on forever without repeating a pattern. Examples of irrational numbers are, and they give you some there. Most famous one would be pi. Pi is the most famous number, irrational number, because pi's value goes on forever. Other vocabulary associated with the real number system: the ellipsis, the little dots at the end, continues without end. That symbol there is a set, a collection of objects. So we're talking about a set of real numbers. It's there. Finite means having bounds. Limited, infinite, there are no bounds. It goes on forever. And a Venn diagram you've seen several times and been learned about before, so it's nothing new. A diagram consisting of circles or squares can show relationships of a set of data. We have a Venn diagram of the real number system. You would put rational numbers on one side and irrational numbers on the other side. However, if you're looking at your set of rational numbers, you see there are several subsets under rational numbers. Classify all the following numbers as natural, whole, integer, rational, or irrational. List all that apply. Now remember, all of your natural numbers are also whole numbers. All of your whole numbers are also integers. All of your integers are also rational. And if it's none of those, it's irrational. Now, remember when we're talking about sets of numbers, and they didn't mention it, when you get to your natural numbers, your whole numbers, and integers, those numbers do not include decimals or fractions. Your decimals or fractions do not come in until you get to rational numbers. So they will not be considered an integer, a whole number, or a natural number. They're only rational. To show how these numbers are classified, use a Venn diagram. So if we place all of these numbers there, we see 117 is a natural number, a whole number, an integer, a rational. 0, whole number, integer, rational. -3, integer, rational. 4/9, 6.36 are both rational numbers. And -12.64039, it goes on and on and on, that is an irrational number. Now that all the numbers are placed where they belong in the Venn diagram, you can classify each number. And we just did that, so we don't have to go through that again. This is very important, very, very important. You need to put this down somewhere. When taking the square root of any number that is not a perfect square, the resulting decimal will be non-terminating and non-repeating. Therefore, those numbers are always irrational. Now, we've not talked about squares or perfect squares yet. We'll talk about those later, but this is something you need to remember. Tomorrow in class, we're going to look at our subset of numbers, and we're going to classify them, and we're also going to order and compare these numbers. So we'll be looking more at number lines and ways of doing that.